Hey everybody, how's it going? Everyone still looks alive on Wednesday, so we're doing something right. Thankfully this is Wednesday and not Thursday, or, the response would be somewhat less enthusiastic, I think. But that's okay. So, my name is not Shri. My name is Dan Illson. I work on the cloud advocacy team here at VMware. Shri is my colleague who originally prepared this material for VMworld in the US, but unfortunately he didn't make the trip with us this time, so I am performing his material and his hits today, but we wanted to make sure we left him up there to give him credit. So, this session today is about security tokens and kind of some of the roles that they play for us, particularly as we go through Kubernetes and some ways to think about dealing with and managing them, because I don't know, how many of you are using Kubernetes today for either for something in production or for something you hope to eventually be in production? Yeah. So it's one of those interesting things, I think, as people start using Kubernetes, they get into discovering that, not only do you have to manage all of the people who access the Kubernetes cluster, but now all of the individual pods and services that are running in that cluster are basically people-like in terms of the permissions they get and the access they get to do things. And so you now have to manage like that level of access to different components as well, right? It's not enough just to manage the people who interface with the system. You have to manage also now how the components of the system interact with each other, what they're allowed to do, what they're allowed to access on another service or a remote data store or something else, right? So the web of dependencies and the web of like access credentials just kind of exponentially multiplies and grows out from there. Thankfully, we're not going to talk about anything in a product that's not out yet, so I think we're all probably safe from this mumbo jumbo today. So a few things we're going to talk about, and then we're actually going to look at, then we can actually, with whatever time we have left, pull up an instance of Vault on my laptop and see if we can make it do some funny and interesting things. So we'll talk a little about like managing secrets, and when we say secrets, right, in Kubernetes that means any piece of data that we want to store in etcd that we might use as a type of access credential, right? So that can mean X509 certificates, that can mean JWT credentials, that can mean, spiffy SVID documents if we really want to get down some weird attestation rat hole at the workload level. You can do that kind of stuff too. Talk about how those look in Kubernetes, how we manage those with something like Vault, which for those of you using Kubernetes, are you also using Vault from Hashicorp or something similar for secrets management? Doesn't look like it. So you may be one day if you're not already. That may come in time. So that tends to be one of the more popular ways to kind of manage proliferation of secrets across a fleet of Kubernetes clusters or multiple different entities today. There are some other methods. Amazon has Secrets Manager. Different cloud providers have kind of their own different custom solutions, but Vault seems to be kind of the most popular sort of de facto standard in a way that people use. So my team, myself, and this gentleman wandering around in the back, we maintain a website for a lot of the content that we do and different things. The address is there. That's our Twitter account. If you like what you hear and think there's something interesting in it, there's a whole lot more stuff that the two of us and the rest of our team back in the States have put together, so that can be an interesting place to go. Okay, so why do we need to manage all of our secrets? So look, as the number of workloads that we have and the number of services that make up an application grow, right? No longer are we dealing with models where essentially all of the different pieces of our application live inside one compute structure, right? In the good old days, we built a server. That server had an operating system. Within that operating system might run 2 or 3 or 4 or n number of different pieces of software. They all talk to each other within the box. We didn't really have to worry about their reach extending too far beyond. Maybe they wrote to a database that was somewhere else, but that was probably about it, right? as we move through kind of service-oriented applications and into microservices applications, that big stack of stuff gets broken down and the pieces get spread apart, and they can get distributed across any number of different compute nodes, different systems, and they may not all be directly under the operating group's control anymore, right? So if you're using a database presentation that comes from a cloud provider, if you're using a data ingestion tool or an ML modeling tool or something that comes from one of the cloud providers, right? Okay, so now that service, that presentation is not something you control directly, but your data that you probably care very much about is going there. And so now you have to care about not so much managing that individual component as managing all of the things in your environment that have access to it and are sending it data or receiving data from it, and how that flow looks and the rules that govern it, right? So generally the credentials and tokens and access pieces of this, we all sort of lump together these days under the umbrella of secrets. So then you say, well, that's fine. So we have some credential for some service to access some other service. We'll just code it in there. It's effective, but oftentimes these things get coded in either in plain text or in some very rudimentary encoding like base 64. For example, Kubernetes, if you store secrets in etcd, they're encoded in base 64. They are not encrypted. I will say that again. Your secrets in Kubernetes are not encrypted. Unless you have done something really interesting to make them encrypted, they are not. So if anybody tells you that they are, run away. But this is not uncommon, right? So like these things, yeah, people go, well, just put them into the code, it'll be fine. Except anyone else that can see that code now knows all of your access credentials to everything. Not ideal for a variety of reasons, right? So also because secrets and keys and JWT tokens and all these other things, JWT tokens is redundant, but we'll let that one go. Because all these things are highly structured data, that have a very specific format, they're really easy for people that are good at manipulating data to go look for and find. For example, if you have a colleague that likes to, I don't know, upload AWS access keys to GitHub somewhere, it takes a Russian or a Chinese bot about 5 minutes to find those in a GitHub repository these days. I know because I might have had to turn down instances across every region in Amazon one night because of that. Thanks, Sean. And that's lots of fun. So they are easy to identify, right? And because of that, you do want to manage and handle them somewhat carefully. And then, for teams that are working across big shared environments, public cloud, multi-tenant Kubernetes clusters, et cetera, frequently you'll want people to have different levels of access to whatever that shared resource is. And that means individual or kind of group-oriented credentials with different access, which means you need somewhere to manage and store and keep track of, Sean got this, Dan got this, Shri got that, and net out the end result of what that mess of intended configurations was. Okay? Secrets in Kubernetes, okay? Again, that's why we store things in secrets, okay? What do we do with them in Kubernetes? I will say it again, because there seems to be some confusion on this topic when I talk to customers. Your secrets in Kubernetes are not encrypted unless you did something special. Do not assume they are encrypted. They're not. This is important. There are a lot of people who think they are. Please know that they are not. Base 64, by the way, is a thing like, there's a million websites that'll decode a base 64 encoded credential, right? Like, my little niece who's 4 is probably decrypting those things on her iPad somewhere. Don't worry about it. Kubernetes secrets by default are not rotated, right? You tell Kubernetes what you want to store in etcd, it puts it in there, and until you tell it to do something else with it, it just leaves it there forever. long-lived credentials are generally not a great thing, right? Some concept of rotation or expiry or anything is generally good. Kubernetes has none of that by default. They also can't be revoked, right? They can be deleted, but they can't be revoked. So there's no way to mark secrets in Kubernetes and say, hey, this is, yes, we issued this and we knew when it was from, but like it's not valid anymore. You can't do that. You have to delete it and get rid of it, or do something else in an external system somewhere. But there is no way to say, hey, this one's expired, make a new one. You can overwrite it, you can delete it, you can do all those operations, but they exist. Yeah. So this is another interesting one, right? Secrets can be obtained by mounting volumes on a container where you have access, or looking at environment variables, right? Kubernetes itself does not really differentiate between, if you tell it something is a password, and you tell it something is, I don't know, a string, it doesn't care. If you tell it you want to store it in a secret, it's going to chuck it in etcd and leave it there until you tell it to do something else. So it's not checking to see that your data you put in this secret is a JWT. It's not checking to see that it's an X509 certificate. It's just going, oh, you told me to put something in a secret. Here it is. I encoded it and I chucked it in etcd. I will keep it there for you until you ask for it again. Okay? And then there's very little granular control of access to secrets. There's a little bit that you can do on like the namespace administrative boundary, and there's a little bit you can do with service accounts and service account roles and the bindings that go between those objects, but it's not designed to limit access to secrets, right? So it's at best a clumsy and ham-fisted way to do it. You could try to, but it's probably not recommended in general. So I wouldn't approach it that way. Okay? On the other hand, something like Vault or AWS Secrets Manager or other storage solutions designed for secrets, right? This has all the things that they forgot to include in Kubernetes by default in terms of how you want to look at storing and thinking about secrets that are going to be used mainly as credentials, right? You can put it just about wherever you want, or they will host it for you in exchange for some amount of local currency. The open source version's pretty darn good. Like on my team, that's what we use for most everything. We actually use open source Vault. Enterprise Vault gets you access to their policy as code piece, which is a thing called Sentinel and a couple other things. But for at least what I do, what my team does, and what we've needed, the open source versions work just fine for us so far. It does have a concept of secrets rotation, but you have to tell it how and when you want to rotate things, right? So you can do that via its API, you can do it via its command line interface, but it will not automatically rotate things for you. You'll have to tell it how and when you want things to be rotated. Now, probably the part of this that makes the most sense and why we kind of use it as a centralized store a lot is because of the lease period, right? So what's great about this is the end system, the Kubernetes cluster, the pod in Kubernetes, doesn't have to have a long-lived or long-running credential associated with it. It can ask Vault to give it a credential that will be good for some period of time, right? So I can go to Vault and say, hey, Vault, I need to talk to database XYZ that lives out there somewhere. Give me a credential, and it'll say, good, we looked at the credentialing policy in here for that entity. It says you can have one that's valid for an hour, that's valid for a day, that's valid for one single use, and then will be retired and never heard from again, right? So really powerful in terms of not having long-lived or long-running credentials just hanging out there in space for somebody to grab and exploit and behave problematically with, okay? It's cloud agnostic, yes, but also kind of system agnostic. Vault does not care who you are or where you're coming from, as long as you can formulate the proper API command and know what credential you're asking for. If it is a policy, it will issue you one and send it back in an expected format, right? It's nice that way in terms of not being too opinionated about what the requesting system is or what you're requesting a credential for. It just says, I store credentials, you've asked for one, policy says you're allowed one, here you go. I don't care who you are, what or what you're asking for, as long as it matches the policy statements that I have for that entity. But because it's open source and a lot of people seem to like it, and particularly some of the hashing components these days, lots of nice, strong integrations with other community projects. Their work with the Kubernetes community is ongoing. I'm sure KubeCon US is in a week and a half. I'm sure they'll have some new, nice, shiny things there to tell us about. They seem to have regular updates for the hyperscalers and most of the other kind of common platforms out there. Okay? So, we can, let me bounce over to my other screen here. So, on our lovely team website here, Shri actually wrote a whole blog that documents a bunch of this stuff. And so if you want to like refer back to some of what's going on, it's actually a really nice resource that kind of lays out some of this. That blog was called Secrets Manager versus Hashicorp Vault. Okay, so cloudjourney.io is our main site. You can go there, and if you go type in search Secrets Manager or Hashi Vault, you'll find this one. It's got a lot of good information therein. And let me come down to some of what he's actually done in terms of, there we go. In terms of what he's got running. So, if and wherever you decide to run an instance of Vault, right? So I can run one here on my laptop. We can run one wherever. If and when you decide to run one, right, you'll first need to basically set up a policy to generate tokens, to generate credentials for a specific entity, okay? So in Shri's case, he does this by defining a policy HCL here, which is for a catalog database, right? Catalog database, we have a demonstration app that we use. It's a microservices app that we use for a lot of Kubernetes-based stuff. Really simply, it's basically a web, it's basically an e-commerce store front end. The catalog database holds all of the items that are for sale on the store. It's a Mongo database. The service that talks to it and accesses it is a Golang program that interrogates it and puts all that data into a web page and surfaces it. So what Shri's doing here is he creates a policy and he says, hey, I need a secret for a data store that's called CatalogDB. And any token issued for that is going to give you the ability to do the whole CRUD operation set. So, or no, not delete. Create, read, update, and list the credentials. List the tokens for that credential, right? Then if we want, and I'm not going to do it because we're a little pressed for time today in these half-hour sessions, but then we can write that policy into Vault. Vault stores that policy. It's now accessible via the Vault API so that we can interrogate it from Kubernetes or any other external system. Okay? This is good. This is what we want to see. If we want to see the policies that we have, we can take a nice list of the policies on the command line interface, and then we would expect, in this case, because he added the catalog policy, we would expect to see, in addition to default and root, which will always be there, our catalog policy. Okay? Once we have a policy, that just tells somebody, hey, if somebody asks for a catalog policy token, here's what they're allowed to do with that. Here's what that token is allowed to do once it gets issued. Okay, great. But now we need to create something to serve the actual tokens out, okay? So to create a new token, we have to do a Vault token create according to the policy we just specified, right? So Vault token create, and that'll give us the ability to log into Vault to access that credential if we use the token that we then generated. In his case, he lays it out doing it all on the CLI as kind of a learning step. The reality of this is an API-driven, it's usually going to be an API-driven interaction between the microservice living in Kubernetes, if we're talking about a Kubernetes system, and the instance of Vault itself, which is usually held separately off at some durable location and accessible via DNS, right? So like we would, we're going to add eventually to our own site, we'll have a vault.cloudjourney.io that we'll use as our external secret store for a whole bunch of things, right? So he provides, let me see if I can open this in a bigger format. So he provides kind of what the output looks like, and if I open it up, you get a little bigger. Excuse me. What you'll see here is the token gets created, and so, there's your token that gets created as a JWT. That's a hash of the identity of the person who's accessing it, a duration for how long it exists. This is a nice long-lived token. 768 hours breaks down into probably a month. I forget exactly how that goes. And then it's a renewable token, so you can request Vault to renew it for you. Some, if you can flag it so they don't get renewed, that's if you want to do single or limited number of time use tokens. We see the policy that creates it, an identity policy if we want to tie that back to an identity store somewhere. And then you'll see the success, your now authenticated message when he uses it to log into Vault. Okay? And again, that's just taking that credentialing process, moving it out of the application itself, so you have an external source of truth that you can operate independently from the application. Okay? Once we have some system like that set up, and we have our secrets fundamentally divorced from the application or the environment where we're running, so now we can take the secrets and make them a bit more ephemeral and a bit more dynamic. The reason we want to do this again, this is just to solve the long-lived, durable, exploitable credential problem, right? This is another way of addressing that. If it's a dynamic secret, that means that ongoing process keeps refreshing and keeps changing it. It's a lot harder to steal and use for very long. Maybe you get one use out of it, maybe you get a couple uses out of it, but it's not still going to be good for you to come back to the well over and over and over again. Excuse me. Okay, so particularly good for long-running applications that are going to be out there for a very long time, long-running and leaky applications. Really, really nice for auditing, and auditing who accessed what when. So for any of you that work somewhere where you're bound by some regulatory and compliance frameworks, and especially in Europe, I know that's probably most of you at some level, this becomes a really important source of data to be able to go back and say, hey, I actually can tell you exactly who accessed this system last week, last month, last year, and be able to show, how, when, and what credential they were using for that. Rotation becomes a kind of a key benefit of the dynamic secret, right? You want that rotation, you want it to be continuously reused and refreshed. And then revocation, so somebody leaves the company, a partnership with an external organization or another group dissolves. All these things that regularly happen as part of human and organizational dynamics. I'm sure everybody's been somewhere where maybe credentials don't always get turned off right when somebody's job changes or they leave or something else. That's all the risk surface, especially as we move on and everything becomes more compact technologically and more connected. Not properly and immediately revoking credentials can become a big challenge and a big problem. So we look at that. So I'm going to come back across for a minute to some of what Shri wrote originally while I have a minute or two left. So what Shri does here is he actually sets up a rotation policy against Vault. So let me come down a little further. So in his case, he actually uses Vault in part of his blog to distribute secrets and credentials into AWS Secrets Manager for a cluster and some other entities in there, right? And so what he's doing is basically creating a connector and allowing a path out to AWS according to a Polis 3 and an IAM user role in Amazon. So that's, again, tying that identity component into the actual access of the credentials itself. Again, good for the auditing piece and good for setting a rotation policy based on who someone is according to your system. So he sets that up here, and he basically sets up a token that gives you S3 access. That's all you need. That's all this person with this role in Amazon needs. They need S3 access. That's fine. S3 gets them access to the data store, which is where he put the catalog database inside an S3 bucket for the purposes of this, and then attaches the policy to the user, which lets him look at the leasing identity, which becomes that Amazon role, and then, again, duration time and the access key and secret access key associated with the role itself. The whole point to that exercise and what he was doing here is just to tie these different identity and credentialing constructs together so that you have a complete picture and a complete record of what all these things mean and as these constructs map to each other, not just that you have to track, okay, somebody used this credential, well that's great, I can look up what that credential is and what it's allowed to do, but then I also have to go look at IAM to figure out who this person is and what resources they could have accessed in what region and what accounts, and then trace that across 1, 2, 3 n different systems, right? Becomes really complicated and hard to use and manage. If you can start to tie these things together with some central unifying construct, it becomes a lot easier to manage and do more interesting and more kind of resilient credentialing schemes and rotation schemes as you go. But that brings me right about to, I think, the end of the time I have so that Julia can bring up the next speaker. So I just want to say thanks for coming out and spending some time with me this afternoon. Hope everybody enjoys the rest of the show, and safe travels back to wherever you're going after this. So thanks very much.